How's everybody doing? Last talk of the day. I'm going to ask a few questions, so maybe we can have a little bit of user feedback as we go. But my name's Rob. I'm going to talk today about catching a bus using something called a Pebble Watch and using Python to kind of tie them together. So, first off, the problem statement. I like to take the bus once in a while. Does anybody here take the bus? A few people. What's the biggest problem that you guys face when you take the bus? Anyone? Homeless people.
Not sitting in urine.
Still working on a Python solution for the urine problems. Do you ever have trouble knowing when to be at the stop and catching the bus? And maybe the buses only come like every half hour or something like that? All right, so in the olden days, before there were smartphones, before there were computers, I'll come back to the map, there were these bus schedules that they printed, and you had to pick one up from either like the bus terminal or they hung them on the wall. But go back to the map. I live in the yellow square, and there's two bus lines, 7 and 32. 32's the lower line, and 7's the upper line, and those blue squares are the bus stops. So you can see kind of here, it says Cedar Road in Norfolk, so that's the name of the stop up there. This one's Euclid Heights in Lenox, and this one's Euclid Heights in Derbyshire, so they're all at the cross streets. And this is about a 2-minute walk, and this is about a 2 or 3-minute walk, depending on the lights. So pretty straightforward. We got some intersections, we know where we need to go to get the bus. But then we get to the schedule, and it's like, how do you read that? Like, what? I don't see where my stops are on that. So this is the entire bus line, all condensed into a little graphic. So I think my stop is somewhere around here. I don't know. It looks like it, right? And then when we look at the time stops they give us, we get 7, and there's probably like, 40, 50 bus stops. So I have like a 10-minute span that I might be able to catch the bus in. So that means if I'm going to take the bus to work in the morning, I kind of have to like figure out on my own when I should be out there, and maybe it came on time when it was supposed to, and maybe it was late, so there's a little bit of like cargo cult, because maybe it shows up an hour late, and I'm like, oh, I should catch it now. Nope, next day it doesn't come. So clearly, it's not the easiest thing. All right, so have these printed. These have been around since buses have been around, time eternal, right? So we get the internet, and now people can go to the website. The bus line in Cleveland is called the RTA, and notice how much easier they've made it for you to find your bus stop in time. Nope, it looks exactly the same as the printout. So still stuck where we were before. Go out there, maybe I'll wait for a bus. Half an hour later, maybe one will show up. All right, so this is kind of what we've been talking about. Why taking the bus isn't really that fun. Don't know when exactly I should be there. It comes by me every 30 minutes during peak time and every 45 minutes to an hour on the weekend. So if I miss it, I'm kind of in trouble. And if something happens to the bus, I'm just standing there. So I could be there for 2 hours if something like that happens. Yeah, they're not running to all the bus stops and telling people that the bus isn't coming today. So, in 2012, RTA actually put GPSs on all of the buses, which is cool because with GPS, you should know exactly where the bus is at all times, and it should make it a lot easier for me to figure out when I need to be out at the bus stop. And they actually integrated with Google Maps, so if I do how do I get from here to downtown, it'll come up with a bus route and show me the next times that the bus is supposed to come. But maybe they didn't consult a UI designer or something, but it's still kind of difficult to figure out where I need to go on their website to figure it out. So I don't know if you guys noticed, but you have the first selection is the bus line. So that's pretty easy. It's serial integer numbers 1 through 64, whatever. Okay, I can look that up. Direction, west-east. I don't know what they do for north-south lines because those just don't fit into it. So it's either east or west. And then you'll notice the stops, which are not like destination-based. They're actually alphabetical. So if I accidentally click one above or below that maybe isn't the next stop on the list and I don't read it, then I could be looking at the wrong bus time. But let's give credit where credit's due. These are GPS-enabled NextConnect times, and they'll give me a prediction. So I know at 2:40 p.m. I should be out at the stop, and if I'm not there, then the bus won't be there. So, okay, how do we make this better? Let's see. Yeah, so I can look that up on my computer. I can also look it up on my phone, but same problem persists. If I'm looking for a bus, I gotta select on all of the different inputs, and they reset every time, so I can't bookmark. So if I want 2 different stops, I gotta do all the selections. So I'm talking like 5 minutes to find out when the next bus comes. Not exactly user-friendly. Okay, how about an API? They have all of this data. Clearly, it's stored on a database somewhere. Somebody's looking it up. Can I just send a query and get it in like a nice machine-readable format and do with it what I want? Well, they said back when it came out, as a turnkey closed-source product, the vendor is under no obligation to provide a public API to the data and does not, in fact, currently provide one. So that's where your public dollars get you. So can look it up, but not access for all. So I said, all right, here's where we stand. We got real-time data. Okay, it exists. The website works, but it's not the best solution because I feel like I can't look up the bus and the stop right away when I need to. And there's no public API, so I can't build my own website that just has my 2 stops that I need. So what would Dick Tracy do? That's the question. Wouldn't it be cool if I could take my new-fangled Pebble Watch that connects over Bluetooth to my phone and immediately see when those buses are coming without doing any other operations, just clicking buttons? That's where I want to be. Where I am right now is in the slow lane, looking up stuff on my phone that takes 5 minutes. So we have a few tools that can help us. Python, we'll figure out how to get that data from RTA and use it for our own devices, and then the Pebble Watch, which is going to be our display interface. So does anybody here have a Pebble Watch? You guys like them? So I think they're cool because they're fairly developer friendly. I don't know if anybody's tried to make an app for it yet, but I found it to be really, really easy compared to Android or iOS development. They're not too expensive. You're not paying $500 for an Apple Watch. You can get one for, I saw 40 or 50 bucks used and $90 new. And they're e-ink display, which I think is cool because they last forever battery-wise. So you can, one charge is a week or 2 weeks depending on how much action you're doing on it. Okay, so here's the plan about how we're gonna figure out what to do. We'll build an app on the Pebble Watch that will let us know when the bus is coming for the 4 nearest stops to my house. So that was the map earlier. We're going to use Python to make an API to respond to requests from the watch. And then we'll create a database to store all this stop data and routes that we can use for Python to respond, and then maybe we can run some analytics on it later to see stuff like, I don't know, is this bus late every day or is it just a few days, and how long is the longest wait time? And then we can do stuff with the data. All right, so enter Python. Which one? No, I thought it looked cool though, doesn't it? My other domain is my wife's name and my name.com, debbieandrob.com, but I didn't want to come off as like... So this is the placeholder until somebody thinks of something better. Okay, so Python, if we figure out a way to get the data out of the RTA website, is going to query for the predicted stop times for a given stop, and then it's going to store it in the database, and then using some kind of like web app like Flask or Django, we're going to try to respond to a simple API request, which is just predicted time with a stop ID, and we're going to have 4 stops. Okay, so now's the fun part. So RTA doesn't have an API, but the data is still available because my browser is making a request to RTA's server and it's giving something back that I can read with my eyes. So it's clearly there. It's just not necessarily available for me to read in using Python. So what I did was I opened up the console of Chrome, Firefox, whatever, and I opened up the network tab, and I selected through each of those drop downs to see what was actually going on. So you remember there were 3 drop downs, and they're actually kind of cut off at the top. But I don't know if you guys can read this. It says, get routes, get directions, get stops, and get stop times. And if you'll notice over here, they're not gets, but they're posts, which means I can't just call that from my web app or from my JavaScript because of a cross-domain problem. So if I try to send those in from my busapp.com or whatever, it's going to block me. Yeah, they do. I try. Yeah. Not debbieandrob.com, though. I let that one gets through. So these are actually not too badly formed. If you'll notice, they have a stop ID right here, which just is an integer. You see a direction ID, which doesn't make as much sense because that's 14. So they use 14 for east and 3 for west. I don't know what the other ones are. If anybody is here from RTA, that would be cool. Then we start a dialogue. All right, and then you see a route ID. So what I did was I went through each one until I finally got to the bottom, and I get all of this for mine, and I wrote it down in a text file somewhere. So I know for this stop, the route ID is 149, direction ID is 14, stop ID is whatever that number is. So for the 4 stops I want, I made sure I had the routes, and I made sure I had the stops. And then I looked at the response. So when that gets thrown to RTA, they actually come back with a nice JSON dictionary that is readable, and it's got show schedule time, it's got predicted times. So for each stop, we get 3 possible crossings, which is when the buses are supposed to be there. And they don't all have predictions, but when they know that a prediction is imminent, then they'll give it to you. So, okay, we can't send this request from a browser, but in Python, we can still create a post request, send it, and get the data back, right? So I don't know if anybody's used URL lib, too many L's there, but that's not fun to make requests with. So there's a nice Python library called requests, and you can pip install it. All this code is on GitHub, so if you want to pull everything down, it should have all the requirements, and you can play around with it. But next slide. Okay, in requests, we can do something simple like request.post, post it to those URLs that we found earlier, get stop times, create our data dictionary with the route ID, the direction ID, and the stop ID. Remember the ones I said we wrote down on a piece of paper earlier? And then content type application/JSON. And we just send that through, and we come back, and we get a response.json, which is exactly what we saw in the browser. So we get a nice data dictionary with a key of D, which I assume means data, and then all of the stuff from before, show scheduled, show stop number. I didn't send those through, so I guess those are just defaults. And then a list with all the stops and crossings. So this is good. We can get the data out of RTA, which means we can do with it what we want. I can store it. I can send it to my watch. I feel like I'm powerful now. I have access to the bus schedule. All right. So when I was first testing with this, I had a web server set up, and I just wanted to record the 2 stops that I knew about before I had the Pebble Watch. So I would just hit a URL on my phone like /bus, and I would just have it proxy the request. So as soon as it hit my web app, I would say create a response with the request library, create a request with the request library, and then just proxy everything back to my web app, which is good because I got the information I needed. But it might be a little bit slow if you're doing a lot, or if you want to always know 4 or more than that, maybe we want to introduce a caching layer. So instead of saying, okay, here's the request for the stop ID, return it immediately, let's maybe make a script that every minute or so looks up all the stops we know about and then throws all the times in our database. So the danger is it's not necessarily the latest information because there's some lag between when my script might look it up, but I have the added benefit of adding everything to a database that I can then do analytics on, and I'm not bogging down RTA's server if for some reason every single one of my friends has this and they're all trying to figure out when their bus stops are. Any comments on that? That was just what I decided to go with, but pros and cons. Okay, so let's make a database to store all of our stuff that we get back from RTA. So I said, first I need a routes table that has a route ID that'll just be generated with Postgres. You see a column called the RTA internal route ID. Those are the ones we saw earlier when we looked at the requests from the website going out. So for each of the routes I wanted, I had to write those on my piece of paper, and then I'm going to insert them into my own database later, because I don't know a good way of finding out all of RTA's route IDs. Title is just going to be what we call it, and then description if you want. So 2 routes, 32, which runs up and down Cedar Road, and then 7, which runs up and down Euclid Heights. And you can see the 2 internal IDs, which are 149 and 103, which do not correspond to the bus route ID, which is 32 and 7. But again. All right. I also wanted a table for destinations so that I know where the bus is going. So in this case, the 7 goes to Richmond, 32 goes to Montefiore, but when they're going west, they actually both end up at the same terminus, which is East 89th and Euclid. So this is kind of nice. If I'm storing destinations, then later I can say, oh, instead of looking up each bus when I ask for a request, I can say, what's the next bus that's coming with a destination of East 89th and Euclid? And then I can take 32 or 7, depending on what one's coming first. And then we have stops, the all-important stop. So again, a stop ID, pretty simple. RTA's internal stop ID, which I log. A title, which is going to be something human readable for me, so I know where it is. The route ID, which is 7 or 32, and then a destination. So since a stop that's going west, even though it might be located in the same place, is distinct from a stop going in the opposite direction. So you can see a few examples of inserting. We have Euclid Heights and Derbyshire Boulevard. RTA's ID is 9411. It's going to end up at East 89th and Euclid. And we're just going to select my internal route ID using RTA's. And then we'll add one at Euclid Heights and Lenox. So one's going one direction, the other's going the other direction. And we'll do the same thing for the other bus route. All right. Now, RTA has a schedule that they try to stick to, and then they have predicted stops, which is when the bus is actually going to arrive. So we don't always know when a stop doesn't always have a prediction. So if it's an hour away, they might not be able to, whatever their algorithm is might say, oh, only do the predictions 20 minutes before that. But we still want to display when we think that the bus will be there. So we create a scheduled stops. So that's corresponding to what we saw in that PDF earlier, which is just the times we think the bus is supposed to be there every day. And you might have noticed that in the response, we get back a scheduled time and a predicted time. So every time I do a query, I'm matching that predicted time to a scheduled time. And if I don't have a scheduled stop yet, I'm just going to insert it. So it's kind of the lazy way of doing it. And the first time through, I might not have all the data, but I should build up my schedule as I go. All right, so we have a schema. Let's start adding data to it so that we can start doing fun stuff with it. A quick side note, I don't know what database everybody uses, but I use Postgres, and Python's got a nice library called psychopg2, and it's got this cool function called register composite, which means you can take a table in Postgres and turn it into a Python class. So when I execute that query, s.star : stops as stops from stops, where stop ID is 1, then in Python, when I do cursor.fetch1.stop, that s is actually a stop class. And then I can do fun stuff like look up RTA predictions, which is a method on the class. So just makes everything a little bit nicer. Okay, so let's make a script that's going to run every minute and log all of the predicted times for a set of stops. So get all the stops in the database for each stop, check and insert its stop predictions. Pretty straightforward. That check and insert is just going to call RTAs, the method we saw earlier, using the internal RTA ID and the destination, and then it's just going to do an insert into my predicted stop times table. And then do a commit at the end and checking complete. So we're going to run this every minute. And I just set up a cron job to do it on the server. So every minute runs that script for me, puts all the times in. Yeah. Any questions so far? Seems straightforward. All right. Yeah.
How often did you find that RTA actually updated their either locations or times?
Oh, yeah, sure. So the question was, how often did I find that RTA updated their predicted times? It seemed like they were doing it in real time. So every minute I did a query, I could get 2 different times back on that. And their website was actually set up with a set interval JavaScript timer, and I think it was checking every 20 seconds. So from my 1 minute, I could tell that stuff was changing. I don't know internally how often they're pinging out to that GPS to find out where the bus is, but I couldn't see it being much faster than because diminishing returns at some point. Okay, so we're gonna do that. Every minute should be fast enough for what we wanna do. Okay, so then the next part is, now that we have all the data in the database, we want to write an easy API hook that you can hit from a browser or from a phone or from a watch that'll just give us back a nice JSON object of the next predicted time for a stop. So use a web framework called Horsemeat, which is anybody can download and install. Matt Wilson, who's over there, wrote it. It's pretty good. Or you can use Flask or Django, something that you should just be able to answer a request. So a lot of text here, but the important part is you see that the route string is /API/prediction. So when that hits the server, this is the handle method that gets called. We just grab off the stop ID as an argument, look it up. So we figure out our predicted and our scheduled time. This stop has a get my next predicted stop time. So it's possible that prediction is null. If it is, we're just going to use the scheduled time, and we're still going to return prediction as an empty string or null, so that our watch is going to know how to handle that and what to do with it. We're also going to do some calculations in this handle method called minutes until bus, because if you let the watch in JavaScript do it, I don't know how much you guys have played with JavaScript and date times, but it's not much fun to wrangle stuff into offsets and time deltas. It's a lot easier to do it in Python. So minutes until bus is either if I have a scheduled time, now until the scheduled time, or if I have a predicted time, now until the predicted time. So that way I know, okay, bus is 5 minutes away. I don't have to do the math in my head. And then I'm just going to say minutes until bus, give the prediction, give the scheduled time. And those are just strings with a like 10:05 p.m., whatever. Just so it makes it easy for whatever is reading it to just display it. So There you see a response from the API. I asked for the next predicted time for stop 1. At this point, it was 28 minutes until the bus. It came at 11. It's supposed to come at 11:01. Made the reply at 10:32, so sounds about right, right? Minute off, maybe. Okay, now the fun part, the Pebble Watch. So, the Pebble Watch works really well. It's like a simplified browser display screen. To get up and running with it, there's 2 options. One is download the SDK, install it on your box, get everything up and running. Then you can compile Pebble Watch programs and install them to your phone. Or you can use Cloud Pebble, which is their web-based development solution. And they provide, instead of C++, you can write everything in JavaScript using the custom libraries that they wrote for Pebble. So I'm lazy. I use the Cloud Pebble because it took like 5 minutes to set up an account and get going and send something to my watch. So nice and easy to get going. Few basic steps, go to cloudpebble.net, you create an account. Once you're in, there's one main file that's going to do all the JavaScript execution called App.js, and it kind of just runs from the top to the bottom. They do have libraries for like Ajax and doing fun stuff like vibrating the watch. I'm just going to show you guys some basic stuff. What else? So a few things I ran into. I don't know if anybody's played around with this yet, but a caveat was I had to have the Wi-Fi on my phone enabled. Pebble has like a app that you install, and you have to enable the developer connection so that you can start talking between the phone and the watch. Wi-Fi worked. I don't know why it wasn't working over the data network, but yeah. And I had a Pebble Watch can have 8 watch faces or apps installed on it at once. You'll get an error if those are all taken up and you try to send something to the watch. So I was a little frustrated at the very beginning because I was like, why isn't this working? Well, if you don't have any room left on the watch, it's not going to make it to the watch. So this is just a screenshot of what Cloud Pebble looks like. On the left bar, you can see that we only have one file in the project, app.js. It's just a big JavaScript file. You get a nice little play button on the right-hand side, which is going to compile and run it. And if your phone is connected to your watch over Bluetooth, when you click that, it's going to load everything onto your phone right away. So nice and simple and easy. You can mess with the settings and change the name and what appears on the watch. So for this project, I just needed 2 JavaScript libraries, one called UI, which is to make all the menus inside of the Pebble Watch, and then Ajax, which is what it sounds like, so I can make Ajax requests from the watch. So the Pebble Watch app I did is really simple. It's just a menu of each of the 4 stops, and then when you select the menu item, it's going to show me that response. So it'll show how many minutes until the bus comes to the stop, what the predicted time is if there is one, and when the scheduled time is. So first things first, let's create a stops menu. In Pebble, you just use the library UI.menu. It takes sections, which takes a title. So you can see current stops is the title for this menu, and you'll read it right here, current stops. And then each item in the menu takes a title and a subtitle. So you see Euclid Heights and Derbyshire, and then subtitle, which is the destination and line number of the bus. So there's 4 of them. You can scroll through each of them. And how do we get this to show up on our watch when it starts? Just do stops menu.show. Couldn't be simpler than that. One thing to notice is these menu items do get cut off. So you get a ... Those don't scroll. I looked into a little bit if you could scroll them, and some people have done work with that. But the reason Pebble doesn't want you to have scrolling menu items is the whole screen redraws every time something changes on it. So it's going to eat up a lot of battery power if you have menus that constantly have to scroll through the entire title. So the best thing to do is try to keep your title short so that you can tell what's going on. But those make sense to me, so it works.
And you're able to hide extra data in that items thing, like stop ID.
Yeah, exactly. So you can add any keys you want to that because it's just a dictionary. And I'm going to use that later when I do a selection. Well, next actually. So you can define events on the stop menu, and one of them is select. So select, there's a middle button on your Pebble Watch phone, which is just a select button. When that gets clicked or touched or whatever you want to call it, it's gonna fire off this function. And you'll notice you can actually do debugging and logging live while you have the watch connected through your phone. So there's a live log. I've console.log each of those menu items out. And when I click them, they're going to pop up in this. So you can watch and debug while your watch is running on your computer, which I thought was really nice. So it's not like you got to download that once all the execution's finished. It's live as you're going. So as you pointed out, you can embed other things in that menu item, i.e. the stop ID. So we're going to pull out the stop ID, and then we're going to make an AJAX call to our API to get the stuff we need. So this is the long AJAX call. Looks pretty much how you would do it in JavaScript. You give it a URL, which is, see, I changed the domain again. Now it's busapp.com. /API/predictions, stop, and then the stop ID, which is just one. Type JSON, pretty straightforward. Hits the Python app, comes back with a data object. So let's take what's in that data object and display it. So the important part for this is we have something called a detail card. And a detail card looks like this. It's got a title, a subtitle, and a body. So you can put whatever info in it you want. They style everything a little bit different. And you can change all the styles, but I just kept the default. So you see title is going to be minutes until bus plus the string minutes. And then for the subtitle, we're going to either display the predicted time, which in this case is 10:31, or if there is no predicted time, we'll just display the scheduled time in parentheses. And it works. So I can select a stop, and it'll hit my phone, which will hit out to the Python API and come back. And I can see right away when that bus is supposed to be there. And I can keep hitting that to see if I'm late or if the bus is going to be on time or what's going to happen. So it seems like to me we solved the essential problem of when I should leave the house to get to the bus, because I know exactly when the bus is supposed to be there, as long as the GPS is working on the bus. So we did it. Woohoo. So that's mostly all I have. I mentioned data analytics, so I just ran a simple Postgres query. I've been logging predicted times for about a week. So in that week, I said, okay, for what are the longest times that a bus has been late? And I don't know if this is bad GPS data or just bad bus drivers or what, but you can see in a week, there were 6 stops where the bus was over half an hour late. So the longest one was 1 hour and 25 minutes. It was supposed to be there at 2:15. It didn't show up until I think like 3:45 or so. One was supposed to come at 6:55. It was 1 hour late. One was supposed to come at 7:30. It was 50 minutes late. So you can see how relying on a bus just in a week is sometimes not the safest thing to do. But if you have a watch or a phone app and you know that it's going to be late, at least you can plan your day accordingly like that. So I actually, in the GitHub repo, I put this Postgres dump. So if anybody else wants to play around with it, they're welcome to run queries like, what's the average time for a stop? That might be something cool to display on the watch if you know that this is always 5 minutes late, or during rush hour, our bus is always late, that kind of thing. I don't know. So this is just what I came up with quick, and there's definitely more stuff to look at. That's all I got for you guys. So there's the GitHub link if anybody wants to check it out, contribute to it, whatever. And if you guys want to give me feedback, I think we're testing out a feedback app. And if you go to that, you can tell me how I did with the talk and questions, comments, that kind of thing. All right.
Yeah, please give that a try, because it's a Toronto startup that asked us to pitch their thing.
Can you, the letter in between the P's.
plp.io/pyohio/#CCHC. Give it a try, see if it works. So thanks for listening. Questions or comments?
So how would you make this track like every bus stop in Cleveland, or like every bus stop in Cleveland?
So the question is, how would I make this track every bus stop in Cleveland? And the short answer is there's not like a CSV file that I could download to get all the stop IDs. So we'd somehow have to go out and hit up. There's a routes. I skimmed over it, but there are requests I can make to get all the routes, and for each route I can get all the stops for that. So I can pull that in and add it to the database. Then the question is, if I'm checking every minute and there's like, I don't know, probably 5,000 stops in Cleveland at least, is that going to bog down their servers? Am I going to be able to complete that in a minute? So there might be a separate server that's just doing data analytics that checks every, I don't know, 5 or 10 minutes, every single stop in Cleveland, and then running stuff on that. RTA does, the reason I think partly they haven't made this public is they're a little bit nervous about their data that's coming out, because they had a quote about how not making it public if there's bad data in there leads people to draw wrong conclusions. So clearly, if I say, oh, there's buses that are an hour late just in the first week of logging, that probably doesn't look that great. But at the same time, they're putting it up for public consumption. So I don't know. It's pros and cons of grabbing everything.
I would suspect that there are some subtleties to that if you're going to scale it, you'd have to tie into, like, if a bus gets full, they add a second bus.
Exactly, yeah. I would hope that they're that smart to scale up their buses based on usage, but
Yeah, we haven't seen evidence of that, right?
You had 4 stops. Okay. You had 4 stops, and are those the 4 around your place, or is it your destination? Like, what led you to pick only 4?
yeah, those were the 4 closest to mine. So my house is in between 2 routes, and those were the 2 stops. So if I take them going west, I can get down to where the terminal is for like the rapid transit train. So I can catch either of those to go that. It would be like a 15-minute walk, but if I grab a bus, then it's like 2 minutes to get down to the train. And then the other direction is just out to like shopping or the mall or that kind of thing. So yeah, those were the closest bus stops to me. So they would be the ones I'd be most likely to want to know when the bus is coming. But it would be cool if I could use GPS to say, where am I? All right, when's the next bus coming in this direction? There's a lot of extensible things that RTA is not doing, but somebody could do to make it a little bit more user-friendly. And there's other cities that, like Portland has an open data API, and so anybody can write an app based on their stuff. So then you get the community saying, it would be cool if we had GPS, it would be cool if we had bookmarks, blah, 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 and you get everybody making their own app and spreading it, which I think is good for developing with this stuff.
So how easy it would be transferable to a different repository? Say Columbus have quota system, so COTA. It's different from RTA, but how easy if we just grab the code from GitHub and trying to tweak it and make it usable for different cities?
That's a good question. So the first thing would to see if Coda has already a public API that you could query for stop times to see when stuff was coming. I kind of created the database with RTA in mind, so it has those internal IDs. But if bus stops have stops and routes and destinations, so it seems like you should be able to make a database that would fit every single system's kind of real-world system to be able to look at that. But I would encourage you to pull down the database and maybe use it as a starting spot if you were going to try to do the same thing for Columbus.
Maybe I missed this, but does the Pebble Watch support WebSockets? It's like thinking like, hey, I'm going to catch this bus in the next half hour, subscribe, and then anytime you know, like anytime you get new data into your database on that, just push it through WebSocket. Maybe there's less overhead and better for the battery. I don't know.
Yeah, so it does do notifications. So if I get an email or a text message, it'll push it to my watch. So I didn't play much with that, but I think that would be a cool idea to have an app installed that would just say, all right, I know I care about this. Tell me if it's late. Otherwise, I'm just going to assume that it's coming. But yeah, it seems like it supports notifications, so you should be able to push data to the watch, which would let you do that kind of thing.
Have you found that their predictions are actually accurate?
Yeah, so that's the other question, right? So if this were science, I probably should be sitting out at the corner to track whether those predictions are coming in. In my experience of just like trying to catch the bus, they've been pretty good. Like, it seems like if they say a bus is going to be 5 minutes late, it's 4 or 5 minutes late. I have noticed a little bit, just looking at the data, that sometimes they'll predict it to be 7 or 8 minutes late, and the prediction time, instead of getting longer, will come back towards the schedule time. So if you look up too early, you'd be like, oh, I have 15 minutes, but then the bus speeds up and gets to where it's supposed to be when the schedule time is. So there's a little bit of a danger of missing your bus just because you relied on that earlier predicted time. And I mean, I don't know what their what their algorithm looks like to figure out what that predicted time is. But in the limited hypothesis checking I've done, it seems pretty good. But I don't know where those hour late buses are. I don't if that's like an artifact of bad GPS or if they're really that late. Any other questions?
What's your other Pebble ideas?
Other Pebble IDs? I want to know when I should eat. It should just alert me that I'm hungry. But do you have any good ones? A two-way walkie-talkie would be cool. Yeah, Dick Tracy.
Or like Knight Rider, you could unlock things.
That would be cool. Yeah, a randomly rotating random number that can unlock any keypad. That would be cool. All right, that's all I got. Thanks for listening.